我们要不以后排个班吧，每次来一个人。
每次来一个人。
那啥时候轮流啊？轮换。
我周四。
你不能说周几的。
对啊，对。我下次，你下次，你来下次。
不是上次是赵哥。
上次赵哥，那时间到我了。
下次我。
下次你。
什么东西啊？
对。
排班制度。
OK。然后那个看到没有的要记得加，就是那个 event 没有的要记得加。
那我们是不是可以走了？
对。
走了。
我在这方。 松 them
Should I
are.
back up?
You can move back.
Right here?
Yeah.
Yeah. That's it.
Okay, guys, let's get started. So I was away last week, so my PP student lab substituted me for 2 lectures, and based on what he told me, he covered the rest of relational algebra as well as the basic part of SQL. And my plan today is to finish the discussion on SQL and start the discussion into the kernel of database engine. Basically, today I'm hoping today I can wrap up the review of what's covered in undergrad database class. So I was hoping we can finish that last week, but that was going a little bit slower than what I have anticipated from him. But that's okay. I will use about another 20-30 minutes also to wrap up the discussion on SQL. But before I proceed, there are a couple of things I want to make you aware of. The first thing is I shared this Google sheet with you to sign up for your project, right? So I mentioned at the beginning of the semester you will be working on a team of 2, which I'm hoping to release project 1 after Thursday's class. So it's time for you to sign up. You can sign up for you and your partner through this Google Doc. Just enter your email, UID, and your partner's information as well. If you are unable to find a partner by yourself, please still go ahead and put on your name over here. And at the end of the day, we will do matching for those who do not have a partner yet. Okay? But some of you approach me saying that you would prefer to work on this by yourself, which is totally fine. So if that applies to you, you should send me an email, let me know. But keep in mind, if you decide to work on all these projects by yourself, you are still subject to the same workload. Okay? There's no workload reduction if that's what you choose to do so. Okay? So that's so much for the project setup sheet. The other information I want to give out is I have released project 1 today, which is about relational algebra and SQL. You may find homework 1, not project 1. You may find this homework 1, written assignment 1, under files, written assignments, homework 1. Okay. So homework 1 asks you to basically write some relational algebra, then write some SQL queries. So there are 2 problems on relational algebra, 2 problems on SQL. The 2 SQL problems ask you to access a MySQL database server as well as a PostgreSql database server. So you're exposed to two different database servers to get a feeling how you actually interact with them. Okay? What I want to do now is to show you quickly how you connect to those database servers, which I made an announcement this morning already. But I want to give you a hands-on experience, right, using the lecture today. So I'm going to show you how to connect to the MySQL database server first. Then I will show you how to connect to the Postgresql database server. Okay? So I'm going to demonstrate, there are billions of different ways of connecting to a database server, right? Billions of different ways. What I will demonstrate to you is the most basic, most common way of connecting to a database server, which is to use the official client program come with a database server, right? So the overall picture is as follows. You have some server. Typically, it's a Unix server running somewhere. This is a Unix box. Has nothing to do with the database server. It's just a Unix box. On this Unix server, there are obviously an operating system, which is Unix. And on that operating system, there are many processes running, right? A database server is just one of many processes running on this server. Okay? So I'm going to show you this database server process. Right? So there is my SQL server. This is nothing else but just a Unix daemon program running as a process on that Unix server. You follow me? And similarly, I can on the same Unix server, I can run a Postgresql server. Of course, they can run on different Unix servers, but in our case, I set up both servers on the same box. In our case, this is georgia.engineering.utah.edu. Okay, so that's the URL of the Unix server, and that will be the same URL for both database servers. So database server by default will use the URL or the IP address of your Unix server as its host name by default. Most database servers do that. Okay. So far so good. And database server basically listens to, suppose this is my TCP/IP interface on that server. TCP/IP interface on that server. Okay. Database server basically listens to a particular port. So, for example, my SQL server listens to 3306, that default port number. This is the TCP/IP port. Okay, unless when I set up the database server, I change this to a different port. By default, my SQL server listens to 3306. Postgresql server on the other hand listen to port I believe 535432. Okay, that's the default port number for PostgreSQL. Okay. Now, once you understand this, how do you connect to this database servers? Well, there are some client machines. Right? This can be a desktop, a laptop, another workstation, another server, even your smartphone. Right? Can be anything that has internet access. You can either connect to this port directly using a client program. Of course, you have to use something that understands the interface here. So this is what we call a client program. There are many different client programs you can use. Some of them come with a nice GUI interface that you may prefer to use, such as if you want to connect to MySQL server, a nice GUI interface will be MySQL Workbench. And they have released different versions of MySQL Workbench so that it can work on different operating systems. For example, there's a Windows release, there's a Mac release, there's a Unix release for MySQL Workbench that you can use. This provides a nice GUI interface. Or you can just use the default client program comes with MySQL database distribution. That's just called MySQL. Just MySQL. Of course, in order to use this, you have to have this client program installed on your machine somehow. That make sense? So far, so good? Okay. Now, if you want to connect to Postgresql server, again, you want to use something similar to this, i.e. another client program, but works for Postgresql database server. In that space, you have the most famous one that comes with a GUI interface. It's called pgadmin. All of these are freeware you can download and install. They're not necessarily open source, but they are freeware. You can download and install for free. Okay. And come with different distributions for Windows, for Unix, for Mac. Or you can just use the default client program that comes with PostgreSQL distribution called PSQL that you can connect to. But this one, like MySQL and PSQL, these two client programs do not provide a GUI interface, meaning you have to connect to the database server and interact with your database server using a command line like interface. Okay, so far so good? All right. Once that being said, the next thing you want to understand is where you run these programs, these client programs, do not really matter as long as you have an internet connection that can talk to this port on the server. You can run this on your laptop, you can run this on your workstation, you can even run them on the same server where your database server instance is running. For example, I can run my SQL client program, PSQL program from here, from within the same server, same Unix box, hosting my database servers. Of course, in that case, when you are running this program within the same box, there are of course two ways of connecting to this. One is you go through the standard internet interface as if you were connecting from outside. Or there's a special channel, most database servers do that, allow you to connect locally without going through the trouble of going through the internet and coming back again. Does that make sense? You may wonder why they want you to do that. Well, for security reasons. Sometimes I want to set up my database server such that only local connections, meaning only connections like this, are accepted. You have to be able to authenticate into my Unix box first before connecting to my database server. There is a security reason for that. Do you follow me? Yes or no? Okay. Now, once that being said, you will understand what I'm going to explain next. Sometimes, I haven't done this test myself. You may find that you are unable to connect to these two ports on Georgia server when you work from your home computer. The reason for that is because some firewall setting, right? Somebody set up a firewall somewhere that is blocking your connection to these ports directly. When I set up this Georgia server as well as this two database server, I didn't set up any firewall whatsoever. So they are exposed to any connection coming from anywhere. However, it is on the University of Utah campus network. So it is subject to the firewall set up by the university IT office, which I have no control whatsoever. That's beyond me. Okay? They may have specific policies preventing you from connecting to a port, other than if an exception has been made. For example, typically people make exception for ports like this. These are web ports, website ports. These are SSH ports. Typically, these ports are spared from the block list of your firewall, right? But other than these ports, unless you have a special permission, most other direct connection to any other port on campus network will be blocked. For that reason, you may not be able to connect to the servers directly if you're working from your home network, for example. But if you're on campus network, I don't suspect that will be the case. In that case, you have two choices. You have two choices. One is use the University of Utah VPN service so that you get a virtual network address as if you are on campus network. Then you are within the firewall, then you can connect directly. Okay, how to get a VPN, that's beyond what I'm supposed to cover. You can just Google it. Google VPN University of Utah, it's very easy to set up. Second, if you don't want to use VPN for whatever reason, well, use this approach. Right? Meaning connect to the database server from Georgia server itself. But you may wonder, fine, how do I connect to the Georgia server in the first place? Right? You need, in order to do that, you will need to connect to the port 22 using the SSH protocol. And you need a user ID and password for that. You need an account for that purpose. This account is a Unix account. Has nothing to do with your database server account. It's for you to connect to that Unix server, right? And I have set up 40 such user accounts for this class. And all you need to do is send an email to the TAs, any one of the TAs. And they will request for a user account with your username, password, with your name, your email, and UID. Once you send those information to any of the TAs, they will respond to you with a user ID and password for you to log into Georgia server. And this user ID, this user account not only allow you to connect to Georgia for the purpose of connecting to our database servers, but also later for the purpose of product development as well. Of course, you don't have to do your product development on Georgia server, right? You can do it anywhere on your local box. But I just provide this as a convenience because everything, the Java environment, all the necessary libraries has been properly configured by myself on Georgia server. So if you choose to work on your product on Georgia server, you should be able to just go in and compile your code without worrying about linking any library and so on and so forth. So far so good? So to summarize, these are the ways to connect to the database servers. Okay? So what I will demonstrate today is this approach, meaning I'm already on Georgia. So in fact, let me show you that step. So I connect to Georgia first. Once I'm there, I'm able to run either this or this clam programs. The reason I can run them is because I have installed them already. So don't be surprised on your local machine if you type this command, it says command not found, because that's because you haven't installed these programs. Okay? So the first one I'm going to show you is how to connect to MySQL. So once you are here, so this is how you connect to the MySQL server running on Georgia. If you type a command like this, you are connecting through this local channel. If you want to force this guy to go through the internet port, come back again, you tap -H, stand for the host name. Then you type something like that. This is as if you are connecting from outside. That make sense? So this is the way to connect if you are connecting from your local box, for example. If you don't supply -H parameter, by default it will try to connect to the local server instance without going through the internet port and coming back to the box again. Do you follow me? In fact, if I don't type -H, the effect is the same as this. The effect is the same as specifying -H with localhost, which means you're going through this connection. And this connection, they're using a socket, local socket for connection. Local socket. Okay? Rather than using the TCP/IP port. Okay? So I will just connect. And the password, so is this. Okay. So now I'm connected. Once I'm connected, I can show databases to list a set of databases that you have access to. Each database server has many different databases, okay? And each user account is given access to some, but not all the databases, unless you are the root. This user, CX6530 user, is not a root user of this database server, so you can only see whatever database that I gave you access to. And for your homework one purpose, you're going to use this this particular database called CS6530DB. And this is a simulated database for a university-ish database, right? University-like database. So you can show tables. And that gives you the tables in this database. You can show the schema of a particular table, right? Then you can type some simple SQL queries to get that executed. Okay? And once you're done, you can quit. Okay? So that's how you connect to the MySQL database server. Any questions so far? Now next, I'm going to show you how to connect to the PostgreSQL database server. You will be exposed to both on your homework one. Okay? So to connect to the command is -u, but keep in mind, it must be capital U. This is a difference from PostgreSQL to MySQL. For MySQL, it's -u, lowercase u. For PostgreSQL, you have to use capital U. Capital U. Stand for username. The username is the same for both database servers. They are actually two different accounts. It's just that I set up so that they share the same username and password. But they are literally two different user accounts. One is a user account on MySQL database server, one is a user account on PostgreSQL server. It's just that I set up so that they share the same ID and password. Okay? So far so good? And for PostgreSQL database server, you must specify a database name that you connect to. If you compare this to the MySQL database server, this is different, right? For MySQL database server, I connect to the server without really specifying any database I want to log into. Of course, you can, but in the earlier example, I didn't supply any database name. So by default, once you log in, it doesn't connect you with any particular database. But for PostgreSQL server, you have to specify a database. So in this case, I'm going to use DVD rental database. This is one of the widely used sample database for PostgreSQL. So let me connect to it first. So they ask for the password the same. Okay, now I'm connected to this database. You can show the tables of this database using DT. D stands for describe, T stands for table, so describe all the tables, that's what it stands for. So we'll list all the tables from this database. Okay? And this is, again, part of your homework one. You will be asked to write a bunch of queries against this database. And the schema information of this database is available online, where I have a link provided in homework one itself. Okay. Again, notice that when I connect to the PostgreSQL database server here, I didn't specify any host name. That's because by default, I'm using socket connection to connect to a local database server instance. If you are connecting remotely, you can always specify the -h stand for host name, supply georgia.engine.uk.edu as the host URL, then you should be able to connect. If you're not blocked by the firewall set. So far so good? Alright. Any questions before I return to the lecture today? If you have any trouble using a client program to connect to one of the database, any of the 2 database servers, and post a question on discussion forum on Canvas. Okay, I will be happy to help you with that. Most likely, if you have trouble connecting, it's due to firewall setting or some network issues. You can resolve that either by connecting to Georgia directly or using a VPN service to get a campus network address. Okay? All right. Now let me come back to So Deb told me he covered everything up to the basic SQL part, right? The summary part, right? The division, the nested queries, everything, right? So I'm gonna continue from here. Again, keep in mind this is supposed to be a review of SQL rather than the introduction of SQL, right? So I'm going to go a bit in fast pace to just quickly wrap up the review. Okay? So you can do aggregation in structured query language in SQL. These are the type of aggregation operators it supports. The basic idea behind an aggregation operator is you want to compute some aggregate of interest, like count, sum, or average, or median, or whatever, over a set of records, So the set of records is defined by your from and where clause. Your from clause specifies a list of tables. The semantic of that is you compute the cross product of that. If it's a single table, it's just that table itself. But if it's 2 or more tables, once they are listed in the from clause, you form the cross product of those. Then you filter out records from the cross product by looking at your where clause. Your where clause supplies a bunch of conditions, which is basically for filtering purposes. For all remaining records, that forms the set of records you apply your aggregation operator over. Okay, so it's after the where clause, after you have applied those filtering conditions, the remaining set of records represent the set of records you will apply your aggregation operator over. So for example, if I want to count the number of sailors, I will just do that. In this case, there is no filtering whatsoever. There is a single table in the from clause. So the set of records subject to the aggregation operator is all the sailor records. When you do count over that, obviously you get total number of sailors. And look at another example. I want to compute the average rating for sailors with rating equal to 10. Obviously, I'm using this, a single sailor table, but I have a filtering condition. So only those sailors with rating equal to 10 will survive this filtering condition. And only for those set of records, I'm going to apply the aggregation operator, which is average over age in this case. So these are some really basic examples. A fancier, more complex aggregation operator involves the keyword distinct. So I don't know whether that has emphasized this or not. In relational algebra, by default, projection remove duplicates, right? Projection remove duplicates. And in SQL, select, the select clause is actually your projection operator. Selection is your projection, right? By default, in SQL, selection does not remove duplicates. Let me demonstrate that using an example, right? For example, if I look at if I use this database, so these are the tables. If I describe student table, there is the age column, right? If I select age from student, as you can tell, okay, this may be hard to in descending order.
Order by
Okay.
age.
So if you look at this, you obviously have a lot of duplicates. You have a lot of duplicates. The reason for that is, in practice, even though the select clause in SQL is just like projection, but removing duplicates is expensive. Removing duplicates boils down to either hashing or sorting, which I will talk about this later on. But it's fairly expensive, especially if you have a large number of records. So by default, SQL, being a practical query language, says, okay, I'm going to allow duplicates, unless you explicitly want me to remove duplicates. For example, what I mean by that is you apply a keyword called distinct. And now this time you can tell there will be no duplicates left. You may argue, I didn't notice any efficiency difference from the two queries, whether you remove duplicates or you're not removing duplicates. That's because we're dealing with a fairly small set of records here. Right? Human eyes cannot tell the difference between 0.1 second or 0.15 seconds. Right? But if you go for a much larger set, then the difference will be very notable. If you remove versus if you choose not to remove duplicates. Okay, so once you understand that, you can understand what this means, right? For example, count distinct means that you remove duplicate first, then you do the counting, right? So let me use this example again. If I select count, what this will do is basically count total number of students you have. And this actually will be the same as this, guaranteed. Right? Because whether you're counting the whole student record or you're just counting the age column itself, when you remove no duplicate, it's the same. But if I count distinct, okay, obviously that will be different because that will tell you the distinct number of age value you may have. However, if I do this, can someone tell me what will be the answer? Count distinct heuristic. 104, right? Because in fact it doesn't allow you to do this. But semantically, what you're saying is I want to remove duplicate from the student table. Being a relational instance in the first place means that there should be no duplicate student record anyway. So removing duplicate or not in this case has no effect to the final results. And MySQL actually smart enough to detect that there's no need to do distinct in this case. So it doesn't even allow you to run that. Okay? So once you understand this example, the remaining one, sum, average, you get the point, right? The only trick is for min and max, whether you use distinct or not, they're indifferent to the fact whether you're using distinct or not. The reason is min and max are what we call duplicate insensitive aggregates. Duplicate insensitive aggregates. Right? Why? Because they do not affect, whether you have duplicates or not, do not affect the min and max value from a set. Okay. Alright. So once we have aggregation operator, we can run some pretty interesting queries. For example, I want to find the name of the oldest sailor. I want to find the name of the oldest sailor. You may wonder, this sounds like a really simple query to run, right? I don't have sailors here, I have students here. So I want to find the name of the oldest students. First of all, let's run a simpler query first, which is find the oldest age value from the student table. That's easy, right? You select max. Right, just do that. That's 99. If you want to find the name of the oldest sailor, you say, okay, let me see what's the schema of this. So it's S name. So you say, I'm going to do this. Okay? The oldest age, the name of that student. If you run this, it doesn't work. Right? It doesn't really work. It doesn't even allow you to run this. The reason is, if you think about it, this is the aggregation operator supposed to apply over a set. This is a projection. How can you run aggregation over a set with projection on each single record? It doesn't make sense. It doesn't make sense. Follow me? Right? So, of course, some database server allow you to do this, which in my opinion is not the right way to handle this. And what they will do is, okay, you want to do projection of student name, I will do that. Then I will pair each student name with the max age value from that set. So you get a list of student name, each with 99 years old. Or some other data server will say, okay, you want to apply an aggregation, which is over a set, okay? Meaning you want to produce a single record as output. So I will do that, 99. Then for the student name, you want me to print out a student name. So I will print out just the first student record I encounter. The name of the first student record I encounter. But not the student with the max age value. You follow me? Neither of those is correct. Right? So MySQL used to do that. Used to just output 99, the max age value, and whatever the first student record's name, and use that as output, which is confusing, which is very confusing in our opinion. So the latest, this is running the latest MySQL Server 5 point whatever, I forgot. And since some version released, they fixed that. They no longer accept this as a valid input query. Right? So the right way to do this is to use a nested query. Right? The idea is there are a couple of different ways of doing this. One way is you say, okay, you want to find the name of the student, of course, and age of that student. Right? What you're saying is, okay, I want to find the student record whose age is max age from the student set. Table here. Okay, so that's one way of doing it. You follow me? Yeah. Another way of doing this is to say, okay, your age must greater or equal than all student age. That's another way of doing this. Both ways are fine if you think about it. But the point is you have to use a nested block to get this done. Logic is actually very straightforward. But the first time you're doing this is a little bit confusing. You will say, okay, I just type name and max age. That should get me the output. No, it will not. Okay. So far so good? So these are the two approaches. Now, once we understand aggregation, naturally we will introduce the next really useful construction in SQL, which is partition, the idea of partition. Why this is naturally connected with aggregation? Well, oftentimes you want to do some analytics with respect to some form of partition of your data sets. For example, instead of saying I want to know the total number of students from the University of Utah, I want to know the number of students in the University of Utah, but report that by different departments. Meaning, I want to know the number of students in each department at the University of Utah. So there's CS, there's math, there's that. So one way of doing this is very simple. You say, okay, select count from students where major equal to CS. Then you keep typing the same SQL query, I don't know, 20, 30 different times. Or more than that. I think the University of Utah may have over 100 departments. Okay, tedious but doable, right? I type this query 100 times. Every time I change the department name filtering condition to a different department name, I can do that. Right? But imagine if you have, I want to know the size of all stars in the universe. There are billions or millions at least stars. Are you going to type the same query a million times and each time change the star name to sun number 1, sun number 2, whatever, right, you call it, right? No, you're not going to do that, right? It's too much work. So there must be a way to do this efficiently, and that's the group by operator, group by operation. Right? So for example, I want to know the youngest sailor age for different reading group. If reading has just 10 group, very easily you can repeat this 10 times, but reading has hundreds or thousands of different values, you have to do this hundreds or thousands of times. So naturally, this introduced the next clause called group by clause. The idea is you partition your data with respect to some values of your records. You partition your data with respect to some values of your record. And you specify that, the partition condition, using something called the grouping list. The grouping list is nothing else but a set of records that you will do the partition over. You will do the partition over. All records with the same values with respect to those attributes in the grouping list will end up in the same group. So for example, if you want to group by a department name, you simply say group by, supply the department name as your grouping list. You can supply multiple attributes to the grouping list. For example, you can say, I want to count the number of students in each department and in each age group. So for CS department, I want to know number of students age 20, number of students age 21. Then I want to do the same for the maths department. How many maths department student age at 20? How many maths department student age at 22? In that case, you supply two attributes to the grouping list. You do group by department name and age. So that will introduce a two-dimension partition of your data set. And so the logic behind this query is, I will do the cross product from the from list, then I will apply the filtering condition from the where condition list, the where qualification, over using the qualification condition in the where clause as the filtering condition to filter away records in the cross product that do not satisfy my where clause. Then for all remaining records, I will do the partition with regard to the grouping list. And then for each resulting group or each resulting partition, I will apply the select clause. Okay? So logically what's happening is, this is your cross product. For those in the from clause, then you apply the where condition. So for example, this is eliminated, this is eliminated. For the remaining ones, for the blue region, for the remaining guys, you partition them according to the group by, to the grouping list. So for example, you produce 3 groups, 1, 2, and group 3. And for each group, you apply the select clause independent of other groups. So that's essentially the idea. One thing to keep in mind, once you understand this, each group produces a single record. This produces a single output. To represent records in that group. Produce a single record to represent the output of, to represent record in that group. That being said, there is an implicit requirement which many students are confused about, which is what can be used in the selection condition here. What can be used in the selection condition? Because you are producing a single output to represent a group of records, which means that whatever in the output must represent some consistent values for all records of that group. Example, if you produce the group by department name, it makes sense to have department name in the output, because for all records in the same group, they guarantee to have the same department name values. That's how they end up in this group in the first place. Records in different groups will have different values by fine, but they are represented by different outputs. But it makes no sense to, for example, to say student to output student name when you are doing grouping based on department name. Why is that? Why is that? Can someone explain to me why it doesn't make sense to have student name as output when you are doing grouping using the department name?
Because there will be many students.
Yeah, because there will be many different students, all with different names within one group. How do I choose a single student name value to represent all of them? Impossible. At least that's not a consistent representation of values in that group. Right? So you cannot use an attribute other than the grouping attribute as the output of your group by query. However, you can use aggregation. So this is not okay, but aggregation is okay. Why aggregation is okay? Because the purpose of aggregation is to convert a set of records into a single representation, either sum or count, whatever, right? So no matter how many different values you have within a group, once you apply aggregation operator, it produces a consistent representation, meaningful and consistent representation of that group. Right? So aggregation is okay. Now, once you understand what I said earlier, now you understand this condition here, right? So the select clause, the target list for a grouping, for a group record must be one of the following. The target list can either be a grouping attribute or an aggregation operation. It cannot be any other attribute. It cannot be any other attribute. I will demonstrate this using an example here. Example, I want to count. Let's again describe students. So let's count number of students at each age value. Then how do you do that? You will do select age. You will do this, right? So this shows you the age value and number of students in each age group. However, it doesn't make sense if you also try to do this. For those groups with only a single student, fine, you can output that student name. But for those, for example, for age 21, there are 15 of them. Which student name do you expect me to output? It doesn't make sense. So if you run this, they will be rejected. This query will be rejected, and they will give you an error message saying S name is not supposed to be in the target list. You follow this example? Okay. All right. So that's group by. There's the example of this. I will skip this. There's the animation you can run over yourself as well. So for example, I want to find the reservation for each red color boat. I do a join between boat and reserve, making sure the boat ID match and the color of boat is red. Then I group by the boat ID. So the purpose of that where clause is to link boat and reservation tables, because the color of the boat is only available in the boats table. So I link them together and I enforce the condition that I only care about red color boats. So by the end of that where clause, I'm left with only red color boat and the reservations on those red color boats. And once I have that, I partition them based on the boat ID. Then I count with how many reservations made on each particular boat. At this point, I know I'm counting only red color boats. Okay? So that's essentially the construction of this query. There's the animation that you can look at this yourself after the class. Okay? Now, next I'm going to introduce the having clause. So having clause is similar. The purpose of having clause is very similar to the where clause, but the difference is you are applying a filtering condition at the grouping level, at the group level. So the where clause, if you think about it, is to introduce some sort of filtering after you do the cross product with respect to all relations from the from clause. And then you do the grouping, right? Then you do the grouping with respect to group by clause. But in some cases, I want to filter out certain groups before I produce the final output. For example, show me the number of students for each department at the University of Utah, but only do so for those departments with more than 100 students. If you are a small department, I don't care. Don't show me the output. Don't include those small departments in the output. Show me only the large departments. Large defined as having more than 100 students. Okay? Obviously, you cannot do this in the where clause, because at the time of the where clause, you haven't done the grouping yet. So you cannot apply this filtering condition at the where clause. So you have to have some new machinery to do this. And that's the purpose of having clause. So having specify the filtering condition after you have done the partition. And the filtering is to be applied over the groups you have obtained. That being said, there is an implicit condition here as well, which is what attributes you can use to specify the filtering condition in a having clause. What attributes you can use to express that filtering condition in the having clause. If you understand what I said earlier with respect to the target list of a group algorithm, if you understand that, you now should be able to understand what I'm going to say next, which is for the filtering condition in the having clause, again, you can use only two types of attributes. One is the grouping attribute itself, or an aggregation operation. Why is that? Because you're specifying some filtering condition to be checked at the group level, which means it must be a consistent, meaningful value to check using the group as a whole. So the grouping attribute is fine because all records within the same group have the same value. You can check them. And aggregation is fine because it turns a set of records in one group into a single representation, single value. But anything other than that doesn't make sense. For example, if you group by department and you say having name equal to Feifei, that doesn't make sense. What do you mean by you partition all students by their departments and then check whether each group has a student name equal to Feifei? Maybe what you want to say is, okay, I want to partition by department and check whether within each group you have one student name as Feifei or not. Intention, I understand, but syntax speaking, this doesn't make sense. Your intention is well understood, but unfortunately, that's not how SQL works. Okay, the having clause is to check group as a whole. Do you follow me? So that being said, let me use an example to demonstrate this. So it's perfectly fine saying having count. So show me the number of students at each age value, but do so only for those age values with more than 10 students. Perfectly makes sense. You can also argue, I want to do so for age greater than 20. I don't care about those young age groups. Makes sense as well, because you are grouping students by age. So also students in the same group have the same age value, so you can check this condition. But it makes no sense saying so you want to say, okay, I want to find this condition and have student name like Mike. It doesn't make sense because S name is not part of your grouping condition. You cannot check this. Follow me? Yes or no? Okay, fantastic. Alright, so that being said, let's continue. So there are some examples I will skip. Okay. Now, in last week's lecture, Dad must have gone over this division operator, how to do that in SQL. The idea behind this is to use the double negation logic, right? If you want to find a sailor who without all the boats, that is translated into this logic that you are going over all the sailors such that there's no boat he or she has not reserved yet. If that's the case, this must be a sailor who reserved all the boats, who have reserved all the boats, right? So that was the logic from this construction, right? A sailor must have reserved all the boats if there's no boat he or she has not reserved yet. Okay, so that's the logic here. It works fine, but it's a little bit tricky to understand, right? A little bit tricky to understand. Another way of doing this is to use group by and having. The idea is, if you are a sailor who have reserved all the boats, then the total number of reservations you have made must equal to the total number of boats. So I can do this using a group by and having clause. The only trick is, when you count the number of reservations made by a sailor, you must count the distinct number of boats he or she has reserved. in order to ensure that indeed he or she had reserved all the votes. Because there could be 10 different votes, and I did make 10 reservations, but it's not necessary that I made 10 different reservations on 10 different votes. I could make 10 reservations on the same vote, or on over 2 votes, or over 3 votes. Neither of those satisfy the condition that I have reserved all the votes. So there must be a distinct keyword when you count the number of reservations made by a sealer. The rest of this is pretty straightforward. Right? You group by sealer ID to make sure all reservations on the same sealer go to the same group. Then you count the distinct votes, and you return only those sealers, only those groups. In other words, where the total number of reservations produced by counting distinct number of votes is equal to the total number of votes you have in your database. So that's another way of doing division. Okay, there is an illustration of this. You can go over yourself. There are some really sophisticated examples that you can do with SQL. I'm going to show you only a single example. The rest of those examples you can explore yourself after the lecture. Right? Let's say we want to find the name of sealers who reserve most number of votes for each rating group. Okay? So sealer have different rating values. I want to find among those sealers with the same rating values who reserve most number of votes. Who reserve most number of votes. So how do you do this? This actually is not that easy to write. This query is not that easy to write. So what you do is, in the innermost block, you say, I want to join the sealer with the reserve and count the number of reservations a sealer has made. So the innermost block, what it does is basically count the number of reservations each sealer has made. That's what the innermost block is doing, right? Of course, with the condition that I only care about those sealers whose rating is equal to the current rating value from the outermost block. Meaning I compare those sealers from the same rating group. So what's the outermost block? Well, the outermost block is basically the same as the innermost block, meaning you are counting the number of reservations made by each sealer. You're counting the number of reservations made by each sealer, with the condition that the number of reservations you made is actually the maximum from all those sealers with the same rating as you. So that's the construction of this word. That's the construction of this word. Okay? Another way of doing this, of course, is instead of using max, maybe I have that. Okay, yes. Instead of using max, which introduces another level of nesting, you can get rid of that level of nesting using greater than or equal to all. Right? So this innermost block stays the same, but instead of introducing another level of nesting, select the max of reservation values from all those groups. You simply say having the current sealer reservation is greater than or equal to all of the reservation made by sealers with the same rating values. Okay? Any question regarding to this example? If you understand this example, you should have no problem working on any SQL queries in your homework problems, in homework 1. This is probably as complicated as you can get, as far as this course is concerned. Of course, in practice, you may write even more complicated SQL queries. But for most practical purposes, if you understand how to do this, you are capable of writing most, if not all, SQL queries in practice. Okay? All right. There's some discussion on insert, delete, update. These are fairly straightforward. We covered them already. This is just a more in-depth review of this. You can review this yourself, including the null values. I will use the last part of SQL review to talk about join operator. So join operator is to connect one or multiple tables, two or multiple tables. We have actually already seen how to connect two tables. You can do so using from clause and where clause. You don't have to explicitly use a join operator per se for that purpose, right? But because join operation is so important, and for the purpose I will explain in the next few slides, database people still decide to introduce a special keyword called join for you to perform the join operation. For most purposes, if you're performing what we call inner join, which you will see in a minute what inner join means, you actually do not need to use a join operator. The combination of from and where will be able to express inner join just fine. But for outer join, later on you will see in the next few slides, you will have to use a join operator for that purpose. Okay. So the way you understand the syntax here, we are using regular expression. Regular expression means the square bracket means this is optional. That's standard regular expression. And vertical bar means alternative choice. Right? Alternative choice. Right? So what this says is you can do from table name join table name, or you can say from table name inner join table name, or from table name outer join table name, or table name from table name left outer join, right outer join, full outer join table name. So this regular expression gives you those possible constructions. Table name join table name inner join table name outer join table name left, right, or full outer join table name. Okay. By default, if you specify only the join keyword itself without inner or outer, it's an inner join. It's an inner join by default. Inner join is the same as, essentially, from and where clause, with the qualification list on qualification, with that qualification list move to the where clause. So table name inner join table name on qualification list is the same as select from table name where qualification list. The effect is identical. So for example, this one is the same as select from sailors, reserves, where sailor ID equals reserve sailor ID. Okay, so this query on top is the same as the from where clause construction. And there is another special keyword called natural join. The meaning of natural join is the same as natural join as we introduced in relational algebra. So if you're using natural join, you can skip the qualification list because the underlying engine will automatically enforce equality condition on common attributes if you are using the natural join keyword. Okay. So fairly straightforward so far. Okay. So this is the same as from series reserve where CLI equals CLI. Now, what's really interesting about join operator is for the outer join. So for outer join, the idea is the following. Okay, if you look at inner join, or you look at from where clause, what it gave you is a set of records who satisfy from the cross product of the input relation, who satisfy the filtering condition you have specified. But what if I want to produce those output as well as those who do not satisfy the filtering condition? For example, produce a list of sailors and the boats he or she has reserved. But I do want to see all the sailors, even if he or she has not reserved any boat. So the logic is as follows. Print me a manifest of all the sailors together with his or her reservation if there is any. Meaning if there's no reservation, I still want to print those sailors' information. I just want to show a manifest. Like this is very common, for example, if you go to an airport, you check in and you're waiting for your seat assignment. You don't have a seat yet. But the gate agent wants to see a complete list of customers waiting to board the airplane, right? Whether you have seat or not. Does that make sense? So that's an example of this, right? And you cannot do this using inner join, right? Using inner join semantic, you will only show the sailors who have made reservations. Or you will only show customer with seat assignment. For those customers without seat assignment or for those sailors without any reservation, because they do not satisfy the join condition, they will be filtered away. So you cannot see them in the final manifest list. Obviously that doesn't satisfy the requirement. So that for that purpose, people introduce the concept of outer join. For example, sailor left outer join reserve. What that means is I want to produce all the inner join results, which is sailors who have actually reserved boats, plus those sailors who do not satisfy the inner join condition. So the only thing you want to pay attention to is, okay, this part is fine. This is essentially your inner join result. What if I have a sailor who does not satisfy the inner join condition, which in this case means he or she has not reserved any boat, yet I want to print out this record. For sailor ID, sailor name, that's okay. But for boat ID, I don't have a value for it because he or she has not reserved any boat. It doesn't satisfy the inner join condition, and you still ask me to output that record. What do I do? Well, I will output null value for it. I will use null value for this part. Okay, so that's the left outer join semantics. Once you understand this, you can understand outer join. For example, I want to show a list of the boats I have, and for each boat, if there's anyone reserving that boat, show the sailor ID information. But if there's nobody reserving that boat, fine, show me the boat information as well. So you will do a right outer join with boat in this case, and you get this outer. Last way, you can get a full outer join. You can do this on both ends. Show me the sailors, all the sailors and all the boats I have in my club. If a sailor has reserved a boat, show them together, but otherwise show them anyway. So I can do a full outer join with reserve and boats. In this case, it happens to be the same as right outer join because there is no sailor who hasn't reserved a boat. That's why the full outer join in this case equal to the output of right outer join. That's simply because there is no sailor who hasn't reserved a boat. So meaning the left outer join in this case equal to the inner join output. That's why full outer join is the same as right outer join. Okay? Imagine if I add a sailor record here, which is 100, sailor ID 100, boat ID whatever, a boat ID, actually because I'm joining with the reserve, so it must be every sailor has reserved a boat, right? Because you are coming from the reserve table, right? Let's assume I allow a sailor record to exist in the reserve table, but without specifying a boat ID. In that case, the full outer join will be different from right outer join. Okay. Lastly, I want to introduce the very last concept regarding SQL. Then I will move on to the discussion of the kernels. So the last concept at the application level we need to understand is the concept of view. The concept of view. So the idea is the follows, right? I have a bunch of tables in my database. And I interact with my data through those table interfaces. But sometimes it's convenient for me to define an abstract view of how I interact with those tables. For example, instead of student, I want to have some representation of CS students because I interact with CS students all the time. Of course, you can do this by saying, okay, every time you want to do something, you say select from student where department equal to CS. Then you do whatever you want to do going from that point onwards. But every time you do this is a little bit a waste of your effort, right? Every time you have to filter students with department equal to CS. If you do this enough number of times, you may wonder, can I have a way to access those computer science students directly without typing that filtering condition all the time? Okay, this introduces the concept of view. You can create a view using any SQL statement. For example, in this case, I can create a view to show me the number of reservations made on red color boat for each red color boat. So the SQL query is from here to here, which is a simple join and move by query. Right? I join the boat with reserve, and I select only the red color boat, and I count the number of reservations made on each boat because I do group by boat ID. And I define this as a view called ret. So what this view ret does now is it holds the information on number of reservations made on each red color boat and the boat ID of each of those boats. And from this point onward, if I want to know the number of reservations made on red color boats, instead of typing this whole SQL block, I can simply type simply type this, select star from ret. Okay? Select heuristic from ret. And the underlying database engine, what happens is will automatically replace this with the view definition, with this whole block. But you don't have to worry about it. You follow me? This actually introduced a couple of interesting problems. Let's try this, right? If I substitute the definition of ret with that whole block, what I'm really doing is select port ID count from by where the whole block, right? Immediately you notice that there's something going on here, right? If the database engine is smart enough, it should be able to realize that this is actually the same as get rid of this block. This whole thing is just the same as doing this. You follow me? But this is not so trivial, actually. If you think about it. In this case, it sounds like trivial, right? It is a trivial example, but if you write something that's more complex, how do you rewrite? This is called query rewriting. How do you rewrite an input query with views to simplify that query to a more efficient representation? This is not trivial. This is not trivial. This is not trivial. Of course, you can do this without any query rewriting. You basically do this. But what you end up with is you produce this whole set. Then, because of this block, you have to go through this set again. So your query cost actually is doubled. Huh? You follow me? Right? So query writing is a very important topic, a very important subject in this space. So that's point number one. Point number two is, so one way of doing this is to substitute the definition of view whenever a view is used in the construction of your query, right? Of your SQL query. Another approach is, instead of substituting the definition all the time, you may argue, why not? So this is my reservation table, this is my reserve table. Why not when you define the view, I produce a physical table called ret with port ID and count. I physically produce this table. This is called, the terminology in database is called materialize. So you materialize this view. You make it a physical table on disk in your storage engine. Now, once you do that, select star from ret becomes select star from this table. You don't have to worry about any query writing or substituting definition of view anymore. You just go directly against that physical table. You get the results back immediately. From efficiency point of view, this is perfect, right? You reduce a complex go-by join query into just a linear scan of a table, because you have done the dirty work of heavy lifting of join and go-by ahead of time. You have done those heavy lifting ahead of time. So at query time, it becomes really efficient. It's just a linear scan. You know what I mean? But there's no free lunch. What's the catch?
You're sacrificing consistency. So if you're trying to read from your view and the underlying tables change, what is the database supposed to do? Is it going to give you an inconsistent read, or figure out how to?
Yeah, actually, I heard the keyword consistency. You are sacrificing the consistency. Or another way to look at it is you are introducing overhead if you have updates. Either you sacrifice consistency altogether, meaning you produce this physical table at the time of your definition of the view, and you ignore any updates what happened to any of the base table afterwards. Meaning the records, the values in the view no longer represent the latest value you will get if you were to execute this view definition against the latest copy of the table. You ignore that. Meaning, as you said, you sacrifice the consistency of your data. Or you say, okay, consistency is really important for me. I don't want to sacrifice that. I still want to materialize the view. Then you introduce overhead in the face of updates. Meaning, if somebody updates the base tables, you need to constantly check whether the materialized view need to be updated as well. You need to do that checking all the time. And this is expensive, right? But of course, in return, if you do all this, either you sacrifice the consistency or you pay the update cost. In return, the benefit you get is whatever queries you're going to write against views become really efficient. Because now it become a linear scan against a base table. So when to materialize the views, in fact, you can think about this as an even more interesting problem. Is this table, this view table could be fairly big. It could be the case that part of this view will never be updated because the corresponding base table, those part of the base tables are not being updated all anytime. So you can actually materialize those without worrying about doing any update. But the part of your views dependent on some of the base table records, they get updated all the time. Then you should not materialize those part of view, but you should materialize the second part of your view. Right? So how do you make those conditions? In an online dynamic environment, that's a really interesting problem to figure out. Right? For example, how do you know? In the concept here is there could be a red color boat, either because of the name of it or because the year the boat was built or some other reasons. Rarely people reserve that boat. Then you should go ahead and materialize that record in your view. Because nobody ever gonna reserve that. So whatever reservation you have already had on that boat, it's gonna be pretty stable over time. So if you go ahead and materialize that, you're gonna be okay. Meaning you don't have to worry about updating that record in the view. But another red color boat, for whatever reason, is very popular. That way, it had a very romantic name, and people reserve that boat all the time. Then you should not materialize that. How do you figure this out? Of course, you can use some heuristic observations, but a fancy way to say that is use machine learning, right? That's just a fancy way to say that. But essentially, it boils down to that. You make some observations over the usage pattern of your boat, and you figure out what to materialize, what not to materialize. And that's essentially, you can do that using machine learning or data mining techniques. Okay? All right, so that's so much about, there's some other discussion on access control, integrity constraint. That covered trigger already, as well as how to write embedded SQL, meaning connect to a database in a high-level programming language environment, such as Java, C++. All of this, in my opinion, are not critical to the understanding of the database kernel, so I decided to skip all of these discussions. If you're interested, you should go ahead and review those materials yourself, but they're not covered in our midterm or final test anyway. Okay? It's not part of the kernel discourse. But nevertheless, as a database user or database professional, if you claim you understand the kernel of database, you better understand the application of database as well. So it's probably a good idea for you to review this material anyway, right? But you can review those yourself after the lecture. Okay? All right, so let's move on to the next part. So now, from today, we're going to dive into the kernel, right? We're going to dive into the kernel. Some of this, actually, I might have touched base a little bit in undergraduate class as well, but here is a more in-depth discussion of these topics. And from today onwards, every component builds on each other. Every component builds on each other, just as you will do in your project, right? Project 2 build on project 1, project 3 build on project 2. One module connect with the next module and so on and so forth. It's kind of like a pipeline process, right? So we'll start with the basic. The basic is where your data goes, right? You have those tables and all that, right? They must go somewhere. All the tables you see in the database so this stuff, and also I will describe the instance, the schema, the tables, all of this must be stored somewhere, right? In order for database later on to be able to retrieve and report information back to you, right? No matter how complicated your SQL query becomes, at the end of the day, it must be converted to some access to some way of accessing this data somewhere, right? So that being said, in order to understand how a database kernel works, we start with the starting point really is where this data goes, So that's why we start with this discussion today, which is called the storage engine, the buffer, the files. Okay. So if you look at database at the overview, those are what we call the application level topics, such as relational model, SQL, functional dependency, normalization. We didn't cover those in this class, right? We only reviewed relational algebra, relational model, and SQL, but there are some additional topics at the application level that we didn't review. And in the system level, in the kernel level, we really need to understand the physical design of your database, the indexing, query evaluation, and optimization. We are currently at this point, physical design of your database, the storage engine, the buffer, the files. So in order to understand the storage engine, we need to understand storage media, the type of the physical material you use to store your data, the physical material you use to store your data in a computer. And the overview, a really simplistic view of modern computer architecture is like this. You have your CPU, then inside your CPU, inside your processor, you have what we call cache. And a cache generally is classified into data cache and instruction cache. If you have ever taken an architecture class, you know the cache within a processor is made of registers. It's made of registers, electrical registers. So with electrons positively and negatively charged electrons represent 1 and 0 respectively. So because electron travels at almost not at the speed of light, but almost at the speed of light, accessing those data stored in a register is really, really fast. Because you are basically traveling at near the speed of light, which is really super fast. However, the downside of that, whatever stored in the cache, is it relies on electricity power to store those bits, 0 1, right? The positive and negative charged electrons. So once you lose power, all this information will be lost forever. This is what we call volatile storage medium, volatile storage. Then going from cache, the next layer in your storage hierarchy is what we call memory, or RAM, random access memory. Why it's called RAM, I will explain that in the next lecture, but memory is a bigger, larger media to store data, but it's also volatile, meaning if you lose power, you lose everything in RAM, in memory. Then going from memory, down the hierarchy is what we call the disk, hard drive, right? There are two types of disk. One is mechanical hard drive, relying on magnetic field to store your bits. The other storage media at this level is what we call solid state drive, also known as flash drive. The difference of the two, I think there's a class coming up, so I will stop right here. We'll continue this discussion on Thursday. Okay?